All right, and next up for ketones, you have some reactions that we need to be able to do. Okay, so this should be easy because it's really the same reactions that aldehydes did, just a little bit of a tweak on them since, obviously it is a different functional group. You might get slightly different outcomes, but you have redox reactions that can be done. So reduction is the first one here. So if I have any ketone, say it's that MEK that we had before. So this is a ketone. If I'm going to reduce it, right, reduction in terms of organic molecules usually means that you're going to lose bonds to oxygen. So I'm just going to take that double bond to oxygen, turn it into a single bond, and then I'll throw that hydrogen on there, and now I have an alcohol instead of a ketone. So again, the aldehydes always turned into primary alcohols, but ketones will turn into secondary alcohols. So you got to remember that as far as our classes are concerned from before, because I might do multi-step reactions again, and you're going to need to know what class of alcohol is that, what's possible, right? So my MEK turned into a butanol, right? A 2-butanol specifically, or a sec-butyl alcohol, whatever you want to call it. So you have to name things if you want to get that extra credit, just like always. But ketone reactions are fairly simple. Just take that double bond oxygen, right? Your reductions here, double bond oxygen turns into a hydroxyl group for an alcohol. So whatever the ketone is, doesn't really matter what you start out with. And it doesn't matter if there's extra crazy stuff on there or not. Right, I could have this pentanone, and I could even throw a hydroxyl group on there, right? So it'd be a hydroxypentanone, right? So if I named this specifically, it would be 2-hydroxy pentanone. I'd have to say a 3 in between here for pentanone because you could have a 2-pentanone. And that's something I actually forgot earlier when we were talking about our naming, right? I didn't throw any extra branches and stuff like that off of there. But again, ketones are going to take precedence over alcohols. So this is first and foremost a ketone, not an alcohol. But when I do my reaction here, when I try and reduce this, nothing happens to the hydroxyl group because nothing happened to the hydroxyl group before. In this context, you could oxidize it, you couldn't reduce it. So I'm just going to react the one functional group there, but now I actually have a diol, right? So just depends on what you got going there, but as long as you have that double bond to oxygen, you should be able to reduce it to make a hydroxyl group out of it. Right? Both of these are secondary-ish, right? But the second one's a diol. Both things are secondary. One was already there. The new hydroxyl group is also secondary. But those are your reduction reactions. That's 1/2 of your redox examples.